Hello everybody, welcome into another lesson. So today we are going to talk about half angle formulas for trig functions. So yesterday we did double angle formulas, now we're going to do half angle formulas. So you have three formulas here. You have the sine of x over 2 would equal plus and minus the square root of 1 minus cosine of x over 2. Now the plus or minus depends on which quadrant that x over 2 lies in. So if it's in the first or second quadrant, you'll take the plus the square root. If it's in the third or fourth quadrant, it would be minus the square root. And then you have the cosine of x over 2. It equals plus and minus the square root of 1 plus cosine of x over 2. And again, the sign on the square root depends on which quadrant that x over 2 lies in. So if that x over 2 angle lies in either the first or fourth quadrants, you would take the plus the square root. If it lies in the second or third quadrants, you would take minus the square root. And then the tangent of x over 2 is either going to be 1 minus the cosine of x over the sine of x, or the sine of x over 1 plus cosine of x. You can use either formula. They'll both work out to the same result. So let's do some exercises here. Alright, so we're going to have a triangle. Let's deal with this in the first quadrant. So there's angle theta, 8, 5, 8, 15, and then that would be 17. Okay. So we want to first find the cosine of theta over 2. So our goal is to find the cosine of theta over 2. Well, let's use the formula. Now, what quadrant is this? If your cosine's positive, you have all positive sides. Your x length is positive. So a good chance then that your theta is going to be positive. Or that your theta over 2 would end up being positive. Because half of a first quadrant angle usually ends up being a first quadrant angle as well. So we'll take positive of the square root of that formula for 1 plus cosine of x all over 2. Alright, so what is, let's see, let's take the square root. 1 plus what is the cosine of, I should say theta. I should probably name that x theta instead, but it works the same way. The cosine of theta is 15 over 17. So you'd have 1 over 15 plus 17, all that divided by 2. Well, this would end up turning into the square root of 17 plus 15 over 17 divided by 2. Which would turn into the square root of 32 divided by 17 divided by 2. Now we just have a complex fraction in the radical. So this would turn into the square root of 32 over 17 times 1/2, which would end up giving you the square root of 16 over 17, which would simplify into 4 over the square root of 17, which can be rewritten as 4 times the square root of 17 divided by 17. So the cosine of theta over 2 in this case is going to be 4 times the square root of 17 over 17. Now let's say we were asked to find the secant of theta over 2. Well, that's going to work out as the reciprocal of the cosine of theta over 2. So take the reciprocal of 4 over the square root of 17. you would just end up getting the square root of 17 divided by 4 for the secant of theta divided by 2. Alright, so there's that. Now, let's say we want to find the sine of theta over 2. So this time we're going for the sine of theta over 2. Well, everything's positive. This is a first quadrant angle. Half of a first quadrant angle, no matter what angle it is, will also give you a first quadrant angle. So we'll take the positive square root for the sine of theta over 2. So the formula for the half angle of the sine function would be the square root of 1 minus the cosine of theta all over 2. Alright, so let's take the square root of 1 minus, now the cosine of theta again is 15/17 all over 2, which would simplify into the square root of 17 minus 15 over 17, all that all over 2, which would be the square root of 2 over 17 over 2. Now we just need to simplify this complex fraction. This would give you the square root of 2 over 17 times 1/2, which would give you the square root of 1 over 17, which would end up being 1 over the square root of 17, which would simplify further into the square root of 17 over 17. So the sine of theta over 2 would equal the square root of 17 over 17. And then we could easily take the cosecant of theta over 2 by just doing the reciprocal of the sine of theta over 2. The reciprocal of 1 over the square root of 17 is simply the square root of 17. So the cosecant of theta over 2 is just the square root of 17. Alright. Then you knew it was coming. We're going to deal with the tangent of theta over 2. So let's go ahead with the tangent of theta over 2. Well, again, this is a first quadrant angle. Half of a first quadrant angle also gives you a first quadrant angle. So we should get a positive result, but we don't have any plus or minus sign, so it'll work itself out to be positive. So let's go ahead now. Let's use the formula for tangent of theta over 2. Take which formula you prefer. Personally, I prefer to use the left formula, the 1 minus cosine of x over sine of x, but the right formula works the exact same way. It's just you'll have to do different steps, but you should get the same result. So let's use 1 minus the cosine of theta divided by the sine of theta. Alright, so let's see here. So 1 minus, what is that cosine of theta? That's 15/17. That's going to be all over the sine of theta, which is 8/17. So this would simplify into 17 minus 15 over 17 all over 8/17, which would simplify into 2/17 all over 8/17. Now we just have a complex fraction. We invert and multiply. You'll have 2/17 times 17 over 8, which should just simplify into 1/4. So that tangent of theta over 2 should give you a value of 1/4. And of course, to find the cotangent of theta over 2, just take the reciprocal of the tangent, which in this case would be positive 4. So the tangent of theta over 2, sorry, the cotangent of theta over 2 would be 4. The tangent of theta over 2 is 1/4. All right. So there is that. Now let's do some exercises here where let's build some triangles. Let's build some 30, 60, 90, and 45, 45, 90 triangles because we're definitely going to need them. So I'm going to build my two triangles here. This definitely looks more like a 45, 45, 90 triangle. 1, 1, square root of 2, and then let's do a 30, 60, 90 triangle. So let's see, 30, 60, 90, 1 square root of 3, and then 2. Okay. So using these half angle formulas, we can find the exact value of angles we could not do before. So let's say we want to find, we're going to do sine, cosine, and tangent on each of these. Let's say we want to find the sine of 15 degrees. Well, before we just had to use a calculator, but using these half angle formulas, we can totally find the exact value. So isn't it true that the sine of 15, wouldn't that be the same thing as the sine of 30 degrees divided by 2? That would be the exact same thing, right? Alright, so let's apply that formula. For the sine of 30 divided by 2, well, 15 degrees is located in the first quadrant, so we'll take the positive square root. So that's going to end up equaling 1 minus the cosine of 30 degrees, the square root of that over 2. Alright, so this turns into the square root of 1 minus, what is the cosine of 30? That's the square root of 3 over 2. This would be all over 2. So this would turn into the square root of 2 minus the square root of 3 all over 2, then divided by 2. Well, this gets interesting now because you're going to end up having a complex fraction. So 2 minus the square root of 3 all over 2 times 1 over 2. That's going to end up turning into the square root of 2 minus the square root of 3 all over 4. Well, at least the square root of 4 turns out to be 2, right? So your final answer should be the square root of 2 minus the square root of 3 all over 2. So that would be the exact value for the sine of 15 degrees based on the half angle formula. Alright, now we're going to do the cosine of 15 degrees. So let's find the cosine of 15 degrees. Well, 15 degrees is still true that that's the same as 30 degrees divided by 2, so 15 degrees is also in the first quadrant, so we'll take positive of the square root for our cosine of x over 2 formula. So this would equal the positive square root of 1 plus that cosine of 30 degrees all over 2, which would turn into the square root of 1 plus, what is the cosine of 30? That's the square root of 3 over 2. All that all over 2, which would turn into the square root of 2 plus the square root of 3 all over 2. That all divided by 2. you have another complex fraction inside the radical, so this would be 2 plus the square root of 3 all over 2 times 1 all over 2, which should give you the square root of 2 plus the square root of 3 all over 4. Well, the square root of 4 we know is at least 2, so this would end up being the square root of 2 plus the square root of 3 all over 2. That would be the exact value for the cosine of 15 degrees. And then, of course, you guessed it, we're going to do the tangent of 15 degrees. Alright, so I'm picking the tangent of 15 degrees, which would be the same thing as tangent of 30 degrees over 2. So let's apply our half angle formula for the tangent. I'm going to use that 1 minus cosine of x over sine of x. So this would be equal to 1 minus the cosine of 30 degrees. All that divided by the sine of 30 degrees. Okay, so this will be 1 minus the cosine of 30 is the square root of 3 over 2, divided by the sine of 30, which is 1/2. So this is going to equal 2 minus the square root of 3 all over 2 all over 1/2. We have a complex fraction, so invert and multiply. You'll get 2 minus the square root of 3 over 2 times 2 over 1, which would just simplify into 2 minus the square root of 3. So the tangent of 15 degrees is exactly 2 minus the square root of 3. All right. Now, we kind of did that already. Let's do one more of these, but we're going to pick a different quadrant entirely. We are going to pick a different quadrant entirely because I'm going to have us find the sine, cosine, and tangent of 112 degrees and 30 minutes. So we are going to start out finding the sine of 112 degrees and 30 minutes. Well, up till now we haven't been able to find the exact value, but ask yourself, what is 112 degrees and 30 minutes half of? That's actually half of 225 degrees. So this would be the same thing as the sine of 225 degrees divided by 2. Now, 112 degrees and 30 minutes, that's in the second quadrant. So we're still going to take the positive square root for our sine function. So this would equal the square root of 1 minus the cosine of 225 degrees all over 2. Now this is going to get interesting. So this is 1 minus, now what is the cosine of 225 degrees? 225 degrees minus 180 is 45 degrees, so that's a 45 degree reference angle in the third quadrant. That actually means it'll be negative. So what is the cosine of 45 normally? That's the square root of 2 over 2, but you're going to do 1 minus negative square root of 2 over 2 because 225 lies in the third quadrant. You'll take all this and divide it by 2. So this will turn into the square root of 1 plus the square root of 2 over 2 all over 2. So this will end up simplifying a little bit into 2 plus the square root of 2 all over 2, all that all over 2. Now we just deal with the complex fraction under the radical. So you would end up getting 2 plus the square root of 2 all over 2 times 1 all over 2, all that underneath the radical. This would simplify into the square root of 2 plus the square root of 2 over 4, and we know the square root of 4 is 2, so the final answer should be 2 plus the square root of 2, the square root of all that, all over 2. So the sine of 112 degrees in 30 minutes is exactly the square root of 2 plus the square root of 2 all over 2. And you guessed it, we're about to deal with the cosine. So let's just change the function here. So now we are going to find the cosine of 112 degrees in 30 minutes, which is the same as the cosine of 225 degrees divided by 2. Well, now here's the thing. What quadrant is 112 degrees in 30 minutes in? It's actually in the second quadrant, which means this time we're going to have to take the negative of the square root since it's in the second quadrant. So applying your formula, take negative of the square root of 1 plus the cosine of 225 degrees all over 2. Okay, well, what is the cosine of 225 degrees? That's based off the cosine of 45, but in the third quadrant, which would also be negative. So this would actually turn into 1 minus the square root of 2 over 2 all over 2, which should simplify further into negative of the square root of 2 minus the square root of 2 all over 2, all that all over 2. So now you have another complex fraction under the radical, so this will be negative of the square root of 2 minus the square root of 2 all over 2 times 1/2, which should simplify this into negative of the square root of 2 minus the square root of 2 all over 4, which for the final answer would give you negative of the square root of 2 minus the square root of 2 all over 2. So the cosine of 112 degrees in 30 minutes is exactly equal to negative of the square root of the quantity of 2 minus the square root of 2 all over 2. And you guessed we're going to do the tangent of this angle. Okay. So we're going to take the tangent of 112 degrees in 30 minutes, which is exactly equal to the tangent of 225 degrees over 2. So we can use our half angle formula for tangent. So this would be 1 minus the cosine of 225 degrees all over the sine of 225 degrees. Alright, so we got 1 minus, now what's the cosine of 225 degrees? That's a 45 degree reference angle in the third quadrant, so this would actually be minus negative square root of 2 over 2 all over the sine of 225 degrees. That's a 45 degree reference angle also in the third quadrant, so that would be over negative square root of 2 over 2. So let's simplify this more. You would end up getting 1 plus the square root of 2 over 2 all over negative square root of 2 over 2, which would simplify into 2 plus the square root of 2 all over 2, all that all over negative square root of 2 all over 2. Now we just got to invert and multiply the complex fraction. So you'll get 2 plus the square root of 2 all over 2 times 2 over negative square root of 2. Okay, well the 2's at least cancel out. You're going to end up being left with negative 2 minus the square root of 2 over the square root of 2, but we should probably rationalize the denominator, shouldn't we? So multiply both numerator and denominator by the square root of 2. You'll end up getting, wow, what do you know? Negative 2. So yes, that would be negative 2 minus 2 times the square root of 2 all over 2, which should simplify into negative 1 minus the square root of 2. So the exact value of the tangent of 112 degrees in 30 minutes would be negative 1 minus the square root of 2. All right. So let's set up here for the final exercises. We're going to do some triangles with these half angle formulas. So I'm going to keep, of course, the half angle formulas up themselves. But what I want to do we're going to erase these. So yesterday when we did the double angle formulas, we were given one trig value and what quadrant it lies in, and we found the trig functions for the double angles. Well, we're going to do a similar thing today, only with trig functions of half angles. So let's see. They give you that the sine of u, I don't know why I'm putting parentheses, they give you that the sine of u equals 5/13. What else are they giving you? They're giving you that pi over 2 is less than u, which is less than pi. Well, when pi over 2 is less than an angle, which is the angle less than pi, that's referring to the second quadrant. So we're going to be dealing with a quadrant-2 angle. Alright, so why don't we draw our triangle here? We'll call this angle U. You have a positive sign, which makes sense since we're in the second quadrant, 5/13. If you use Pythagorean theorem, you would get that this side is 12, which this would be your x length. But you're going to have to negate that x since you're in quadrant 2, so this side would actually be negative 12. You would just take the negative root, which would give you negative 12. Alright, so now let's start by finding the sine of u over 2. Well, here's the thing. If this is a second quadrant angle, let's take any angle in the second quadrant. Let's even go as high as 88 degrees. I'm sorry, let's go as high as 178 degrees. Pretty darn close to 180, right? What's half of 178? That's 89, which would actually put you still in the first quadrant. So u over 2 is going to be in the first quadrant. So that means we're going to use positive square root. So this would end up being the square root of 1 minus the cosine of u all that divided by 2. Okay? Now, what is that cosine of u? That's negative 12/13, so this would actually turn into the positive square root of 1 minus negative 12/13 all over 2, which would turn into the positive square root of 1 plus 12/13 all over 2, which would turn into the square root of 13 plus 12 all over 13 all over 2, which is going to equal the square root of 25 over 13, all that divided by 2. So let's invert and multiply under the radical. You'll have the square root of 25 over 13 times 1 over 2. Well, that's going to end up giving you the square root of 25 over the square root of 26, which would give you 5 all over the square root of 26. Then you just rationalize the denominator. Your final answer should end up being 5 times the square root of 26 all over 26. So in this case, the sine of u over 2 would be 5 times the square root of 26 over 26, which would make sense because u over 2 is located in the first quadrant, which would give you a positive sign. Alright, let me change some minor things here. We're going to go after the cosine of u over 2 this time. Alright, so let's deal with the cosine of u over 2. And again, we talked about how half of a second quadrant angle is a first quadrant angle. So that means u over 2 itself is located in the first quadrant, so we would take the positive square root for our formula. This time it would be this positive square root of 1 plus the cosine of u over 2. So this equals the positive square root of 1 plus, what is that cosine? That's negative 12/13, so we can just say 1 minus 12/13 all over 2, which would end up giving you the square root of 13 minus 12 over 13, all that all over 2. Let's simplify a bit more. You'll end up getting the square root of 1 over 13, all that divided by 2. Now just invert and multiply the complex fraction. You have the square root of 1 over 13 times 1 over 2. That gives you the square root of 1/26, which would give you 1 over the square root of 26, which when you rationalize the denominator, you would get the square root of 26 divided by 26. So the cosine of u over 2 is equal to the square root of 26 over 26, which would make sense considering that's also a first quadrant angle. And of course, yes, we are going to do the tangent of u over 2. But that's like a completely different formula. Well, it's still based on sine of x over 2 over cosine of x over 2, but let's find the tangent of u over 2. Let's use the 1 minus the cosine of u all over the sine of u. So since u over 2 is in the first quadrant, that means we should get a positive tangent. So we'll take 1 minus, what is that value for cosine of u? Well, that's negative 12/13, so 1 minus negative 12/13 all over the sine of u, which is 5/13, which would end up equaling 1 plus 12/13 all over 5/13. So that's going to equal 13 plus 12 over 13 all over 5/13, which would end up giving you 25/13. All that all over 5/13. Let's just invert and multiply now. You'll get 25 over 13 times 13 over 5. Well, what do you know? The tangent of u over 2 would literally just be positive 5. So the tangent of u over 2 ends up working out to be positive 5. All right. So there's a second quadrant triangle. Why don't we start out with a u that's in the third quadrant? I'm just talking about u for once. We'll get to u over 2 in a minute, but we're definitely going to find a quadrant 3 angle. That much is a given. I'm dead set on that. So that means the angle itself, that pi would have to be less than the angle, which means that angle would have to be less than 3 pi over 2. So that would denote the third quadrant. Let's see what they give us for one. All right, so they give you the cotangent of u equals positive 7. The cotangent of u equals positive 7, where u is located in the third quadrant. Okay, so this is going to be interesting. So u, what is the cotangent? That's adjacent over opposite. Now, in the third quadrant, both your sine and cosine are negative. So that means you'll have this side here, negative 7 for your adjacent side. Your opposite side will be negative 1. So let's find the hypotenuse here. We don't know the hypotenuse, so let's use Pythagorean theorem to solve for the hypotenuse. That'd be negative 7 squared plus the quantity of negative 1 squared equals c squared, which would mean that c squared equals 49 plus 1, which would equal 50. Well, the hypotenuse is always positive, so c would equal 5 times the square root of 2. So now we've at least found the length of the hypotenuse to be 5 times the square root of 2. Okay. Now that we have that, we can start taking half angles. So let's go for the sine of u over 2. Now, u itself is in quadrant 3, which would mean your sine and cosine both are negative. However, let's take half of even possibly close to the largest third quadrant angle, which would be 268. What's half of 268? That's 134, which would put you in the second quadrant. So u over 2 is in the second quadrant. That means you would actually get a positive sign. So half of a third quadrant angle is a second quadrant angle. So since u over 2 is in the second quadrant, you'll take the positive square root. So should end up getting the square root of, let's see, positive square root of 1 minus that cosine of u over 2. Okay, so the positive square root of 1 now minus what is that cosine of u? That's going to be minus that negative 7 over 5 times the square root of 2. That's going to be a little bit hideous. All that all over 2. Well, this would turn into the square root of 5 times the square root of 2 plus 7 over 5 times the square root of 2 all over 2. This is not going to be a pretty answer, but it's going to be what it's going to be. Okay, so now let's simplify this radical even more. Invert and multiply the complex fraction. So 5 times the square root of 2 plus 7 all over 5 times the square root of 2 times 1 over 2. Well, that would end up giving you the square root of 5 times the square root of 2 plus 7 all over 10 times the square root of 2. But what do we have to do? We have to rationalize the denominator, don't we? So this would actually end up equaling the square root of, let's see, that'd be 10 plus 7 times the square root of 2 all over 20, which for the final answer would end up giving you the square root of 10 plus 7 times the square root of 2 all over, what's the square root of 20? That's the square root of 4 times 5. That would just be over 2 times the square root of 5. So, and it's best we don't try to rationalize that denominator. That would be hideous, trying to multiply it by the numerator. So your answer should be positive square root of 10 plus 7 times the square root of 2 all over 2 times the square root of 5. Alright, and we're going to deal now with the cosine of u over 2. And this is where it takes a bit of a twist. So let's do the cosine of u over 2. Now, we've already determined that half of a third quadrant angle is actually a second quadrant angle. So half of a third quadrant angle is going to be a second quadrant angle. So that means for the cosine, u over 2 is in the second quadrant. That means we need to take the negative square root this time. So we'll take the negative square root of 1 plus cosine of u over 2. So this would equal negative of the square root of 1 plus, what is the cosine of u over, what's the cosine of u? That's negative 7 over 5 times the square root of 12. Let me make this radical a bit bigger. So that would actually equal 1 minus 7 over 5 times the square root of 2. All that all over 2. Well, let's simplify this. You'll end up getting the square root of 5, so the square root of 5 times the square root of 2 minus 7 all over 5 times the square root of 2, all that all over 2. So let's deal with the complex fraction. You'll get the square root of 5 times the square root of 2 minus 7 over 5 times the square root of 2 times 1 over 2. So that's going to end up giving you the square root of 5 times the square root of 2 minus 7 all over 10 times the square root of 2. Well, let's at least rationalize the denominator in the radical. So that's going to end up giving you the square root of 10 minus 7 times the square root of 2 all over 20. Well, square root of 20, square root of 4 times 5, so your final answer, and I forgot the negative sign here, is going to end up being negative of the square root of the quantity of 10 minus 7 times the square root of 2 all over 2 times the square root of 5. So remember what quadrant u over 2 is going to be in. you would end up getting negative of the square root of 10 minus 7 times the square root of 2 all over 2 times the square root of 5 for the cosine of u over 2. And of course, we're going to find the tangent of u over 2. Tangent, in my opinion, is a little more friendly to work with than the other two, but let's take the tangent of u over 2. So once again, half of a third quadrant angle is a second quadrant angle. So that means then that your tangent is actually going to end up getting a negative result. So let's do 1 minus the cosine of u all over the sine of u. Well, what is, let's see, we have 1 minus, what is that cosine of u? That's negative 7 over 5 times the square root of 2 all over the sine of u, which actually ends up being negative 1 over 5 times the square root of 2. So this would actually turn into 1 plus 7 over 5 times the square root of 2 over negative 1 over 5 times the square root of 2. Let's simplify a bit more. You'll end up getting 5 times the square root of 2 plus 7 all over 5 times the square root of 2 all over negative 1 all over 5 times the square root of 2. Now let's just take care of the complex fraction. So you would get 5 times the square root of 2 plus 7 all over 5 times the square root of 2 times 5 times the square root of 2 over negative 1. Well, good news is at least one set of radicals canceled out. In the end, you should just end up getting negative 7 minus 5 times the square root of 2 for the exact value of the tangent of u over 2. And that makes sense because u over 2 is in the second quadrant. All right. Now, I got one more I want to do, and you guessed it, we're going to go in the fourth quadrant. So yes, we are going to do a fourth quadrant triangle. Then we'll be done with the lesson. So let's see here. We are for sure, well, let's change this. Because we're going to be in the fourth quadrant this time, which is going to change a little bit of stuff here. So this time, we're going to mention that 3 pi over 2 is less than angle u, which is less than 2 pi, which would fit an angle in the fourth quadrant. So we're definitely going into the fourth quadrant here, but, oh, we have a good one. The tangent of u equals negative 8/5. Well, this is going to work out quite nicely. So u itself equals negative 8/5. It's in the fourth quadrant. U is sine over cosine, opposite over adjacent. So here's your sine, negative 8, your cosine, positive 5. Because yes, in the fourth quadrant, your y is negative, but your x is actually positive. Now, before we go any further, let's find the length of the hypotenuse. So let's take 5 squared plus that negative 8 squared, set it equal to c squared. So that means c squared equals 25 plus 64, not 69, which would be 89. And the hypotenuse is always positive, so you would get c equals the square root of 89. So now we just found the hypotenuse to be the square root of 89. All right, so now that we found all that, let's start by taking the sine of u over 2. Okay, so let's talk about a fourth quadrant angle. What's half of a fourth quadrant angle? Well, half of 270 where it starts is 135, half of 360 where it ends is 180. That means you're still in the second quadrant. So half of a fourth quadrant angle is also going to be a second quadrant angle. So that means for the sine of u over 2 itself, we'll take the positive square root since it's in the second quadrant. So the positive square root of 1 minus that cosine of u all over 2, so that's going to be the square root of 1 minus, now the cosine of u itself is positive 5 over the square root of 89, all that all over 2. So that's going to equal then the square root of 89 minus 5 all over the square root of 89, all that all over 2 under the radical, which now let's deal with the complex fraction. You'll get the square root of 89 minus 5 all over the square root of 89 times 1 over 2. Okay, so let's simplify this a little bit under the radical. So this would end up becoming the square root of 89 minus 5 all over 2 times the square root of 89. Well, I think we should at least one more time rationalize the denominator. So what are you going to get if you do that? You'll end up getting 89 minus 5 times the square root of 89 all over what's 2 times 89? That would be all over 178. Well, are there any even roots of 178? I sure hope so, because it's not going to be a pretty situation. Come on. No. There isn't, unfortunately, so that's the best you're going to get, is the positive square root of 89 minus 5 times the square root of 89 over 178. A really nasty result, but you will sometimes have that. Okay. And yes, you guessed. Let's talk about the cosine of u over 2 now. Let me modify this formula slightly. Alright, now we discussed that half of a fourth quadrant angle is a second quadrant angle. So if we're going to find the value of the cosine of a second quadrant angle, that means we need to negate that square root. So we're going to slap a negative sign on the front of that square root. Now we can deal with this. So you would end up having negative of the square root of 1 plus what is that value of the cosine of u? That'd be plus 5 over the square root of 89 all over 2, which would end up being negative of the square root of 89 plus 5 all over the square root of 89, all that all over 2. Well, okay, this would end up being, let's simplify further. This would end up being the square root of 89 plus 5 all over the square root of 89 times 1 over 2, which would be negative of the square root of 89 plus 5 all over 2 times the square root of 89. Well, we should at least rationalize that denominator in the radical. So this is going to give you negative of the square root of 89 plus 5 times the square root of 89 all over 178, which we did not have any way to reduce. I don't think we did, at least. Nope, we didn't. Oh well. Or did we? One more number. Nope, there is no way. I was correct. So the cosine of u over 2 should be negative of the square root of 89 plus 5 times the square root of 89 all over 178, which would check out because u over 2 is in the second quadrant. So one more exercise, then we are done with the lesson entirely. Alright, and you guessed it, we're going to find the tangent of u over 2. Well, alright, so again, half of a fourth quadrant angle is a second quadrant angle, so we should get a negative result on the tangent. So let's use the 1 minus the cosine of u formula all over the sine of u. Okay, so 1 minus, what is that value of the cosine of u? Well, that's 5 over the square root of 89. All over the sine of u is negative 8 over the square root of 89. Okay, so this is going to turn into the square root of 89 minus 5. All that all over the square root of 89. All that divided by negative 8 over the square root of 89. So complex fraction, we'll just invert and multiply. You'd end up getting the square root of 89 minus 5 over the square root of 89 times the square root of 89 over negative 8. At least one set of radicals canceled out. The best thing you can hope to do here now is you would simply end up getting 5 minus the square root of 89 over 8. So the tangent of u over 2 would be 5 minus the square root of 89 over 8. So that's it for the half angle formulas. Next lesson we'll get into power reducing formulas, which are based off of product of sum formulas, which we'll do in the lesson after that. So I hope everyone has a great night. Take care.